Good day everyone, welcome to this video. In this video I'm gonna show you how to code a color sensor system in a PIC18 microcontroller in assembly, specifically the PIC18 F45K22 microcontroller. So in essence what this video will try to show you is how to achieve color sensor system. So what it's gonna be, what this here is like a hardware schematic. I'm not really in a how do I say it? It's quite inconvenient at the moment to get parts to actually build a system. So all I have for now is the coded version and trying my best to see how it works out, and just using MPLAB resource, but the theory is sound, and I can show you the major parts that are all working in the code, and that should be good enough to move forward with actually trying to achieve this system. Alright, so this is a basic schematic for it. So these three LEDs are indicator LEDs. Obviously this is red, this is green, and that's blue. And as well, as you know, it's a color sensor, so you're probably gonna need a phototransistor to sense the color, serve as the sensor input for the system. So this is how you wire up the phototransistor. You would add a huge resistor there in series with it to make because in essence a phototransistor works by changing the amount of current that flows through it. Well, the current that flows through a phototransistor is proportional to the amount of light that shines onto it, the amount of light that's on it. So in essence, putting a big resistor there makes it such that here it becomes the voltage at this point then changes proportionally to the amount of light that shines on the phototransistor there. Obviously there's probably more detailed explanation about that somewhere on the internet, so you should probably go read up more on that. And now this is the actual this is an RGB LED. Well, this is also an RGB LED, but this is more for indicating, and this RGB LED is actually for sensing. So these two go together. So what you probably have is going to be so let's say, how do I say it? Let's say right here, imagine this is an LED, and this is the phototransistor, right? And this is the color that you're trying to sense down here. Let me give it that another color, say red. Alright, so you're trying to sense a red, something red, maybe a red paper, a red object. So this is your RGB LED, this is your sensor over there. So in essence, you're going to be controlling, you're going to shine the LED is going to be shine onto that, and it's going to reflect off and sensed by your phototransistor. So LED shines there, reflects off, and then the phototransistor gets the measurement there. Well, in essence, your microcontroller then gets the digital value of the analog measurement via the ADC converter. Just go back there, and and now to the next part. So this is to control the LED. So for this particular system, now this is just one method. Before I carry on, I just want to say this is just one method to actually achieve a color sensor using a microcontroller. There's another method which is just using a white LED. In essence, you use a white LED here instead of an RGB LED right here. Let me actually zoom into that. So instead of using an RGB LED here, you just use a white one, and it stays on permanently, and the white LED just shines on all surfaces. And obviously, depending on the surface that's been shined on, this particular the measurement of the voltage transistor will differ with different surfaces. But with this particular method, usually the circuitry is quite complicated. You have to cause the voltage without using a huge resistor in series, as is done here in the schematic. The voltage across here is very tiny, so in essence you have to modify that voltage to get it within a certain range. Sometimes you have to give it gain and offset using an op-amp circuitry, specialized op-amp circuitry, and that method is not always straightforward, so that's one thing to consider with regards to this. But this method of color sensing is actually a lot easier. It's a little bit more complicated coding wise, but the hardware is very straightforward and simple, and in essence to code it is the reason for this video. That's just what I'm going to show you. So first off, the theory of it is basically just okay, I don't really like the word theory. It seems like I'm gonna go in depth in gonna go really deep on some topic, but I'm not really. I'm just gonna explain quickly these three objects. So this particular red square, or weird rectangle, whichever one you prefer. So this square over here is red because it reflects more red than any of the other colors, and this is green because it reflects more green than any of the other colors. So if you have a if you have a green piece of paper in front of you, it essentially sort of absorbs all the other colors. So let's say you shine a white light on it, it would absorb every other spectrum, every other color, like red, blue, whatever. It absorbs everything and reflects green. That's why it looks green. And here, this blue, likewise, it when it absorbs all the other colors. Let's say you shine a light on it, it absorbs all the other colors and reflects only blue. That's why it looks blue to you, to the human eye. So in essence, that method is actually used to achieve a color sensor. How is that possible? So now we go right back down here. So first off, what we do is, on the object we're trying to sense, we shine red, green and blue lights onto the object. So if we shine so what we do is we shine a red first on the object, and after we shine it, it triggers a certain voltage in the phototransistor. So we save that voltage level. We actually save it in the microcontroller. It's a value between 0 and 255 because we're operating the ADC in how do you say it? We taking an advantage of 8 bits, the values. So we're working with 8 bits basically. It's actually 10-bit ADC, but based on it's much simpler to just use 8 bits coding wise. When you're coding in ASM, it's much easier to work with 8 bits, you know, manipulating wise, etc. And so back to it. So shine the red first onto a surface, shine the red, and we'll flash it for like 10 milliseconds, flash it onto the surface. It reflects back to the phototransistor, triggers a voltage level. We save that voltage level, in essence a digital value, in the microcontroller. And then after that, we'll make sure, because we flashed it, we'll make sure the red is off, and then we flash a green. Same thing, triggers a voltage. We save it, turn the green off, and we flash a blue. And we flash a blue, in essence turn it on and turn it off, and we save that value for the blue. And now we have 3 different values, because this surface is red. Remember the basic theory. The red value that was saved when we flash the red will be much higher than the green and the blue value that was saved. That's how it should work. If your sensors are calibrated properly, which is a hardware thing, and the calibration is essentially just getting your making sure your potentiometer is at the sweet spot. I'll explain that a little bit later. And in essence, if it's a green surface, if it's a red surface, the red value will be bigger than the green and the blue value. But if it's a blue surface, the blue value saved will be bigger than the green and the red. So I'll explain again. So we'll flash the red first here, we'll flash the green second, and we'll flash the blue third. And when after each time, so we'll flash the red first and then we'll reflect, it changes the voltage level here. And what happens, it saves that voltage level. Then we'll flash the green, reflects back, saves that voltage level. Flash the blue, saves that voltage level. Now we have 3 different values. Now in the code, we have to compare those 3 different values to find out which one is bigger. Whichever one is bigger, that's the color we're on. That's the particular color we're on. And obviously, if you wanted to sense white and black values, you would obviously have to put a threshold in there to say, okay, if the voltage level for green, if the green value was higher than this particular number, then it's probably a white color, probably white, probably unwhite. We're not on any one of these 3 colors. And if it's lower than a certain voltage, probably black. The color we're seeing in front of us is probably black. And yeah, so that's a basic theory. It will make much more sense as I show you the code. So this is the code, and what the code does, this is the main function, is it does a large test. So this is for calibration purposes. It's for sorry, not calibration. It's for the sake of this example, just to show that this large test works. And let me just comment that out to just show how the code should be in actual fact. Just go back. And this is how the code should be actually. And so first off, in the main function, this is where we are. Main function, we sample the RGB sensor, and then afterwards we do the large test, and then we'll call the RGB LED. So this is for the RGB LED output indicator, and function to test to determine the largest value, right? Hence determine, and hence in that sense we determine and type that. Hence we determine the color in front of sensor. There you go. Color in front of sensor. So first off, I'm gonna go to the sample sensor RGB. So first off, the pin connected to the red LED to shine it. So let me first clarify. So just to clarify again, this particular RGB LED is just an indicator. Okay, it just indicates that it's either red, green, or blue. It literally just shows you. It's for you to see, the user, you, to just see, okay, the sensor sees red, the sensor sees blue, or it sees green. That's all this is for. And now this over here, this right here, is the actual sensor. This RGB LED here, this is the actual sensor. And this right here is the circuitry to actually turn on each LED. And as you can see, there's a photo transistor, there's a regular transistor here, an NPN transistor. we actually need that because sometimes, I don't know, for whatever reason, sometimes you might want to have several sensors, right? You might want to have several sensors, and if you have several sensors, you're going to want to connect the LEDs in parallel, right? Connect the LEDs in parallel, right? So you want to be able to control multiple LEDs from one pin of the microcontroller, and the NPN transistor helps you to do that beautifully. So in essence, what that happens is, once you go high here, this NPN transistor closes, obviously, and then the current flows. This is a what you call it, a variable resistor, and as you vary that, it varies the brightness of all LEDs. So let's say this is red, so let's say you wanted to connect 3, 4, 5, I don't know, however amount of LEDs you wanted to connect in parallel, you connect them in parallel as such. But remember, it's connected here, right? So what you have is, this is connected to ground, and this is connected over there, which is connected to power. So how does this work? For your LED, for the LED to come on, there has to be power. So let's say this is off, right? Now you got 5 volts, and now a current flows, because this is a voltage source. Now the current flows through, right? And you see that red point is connected there, and then the current flows right through, and then you see the LED comes on. But if here is off, well, that scenario I just described is if this is 1. But if this is 0, this is open, nothing, no current will flow. No current will flow from here through to the LEDs, and it will be off. And in that way, we're able to control several LEDs in parallel with one pin from the microcontroller. So that's the purpose of this. And we have that same scenario for the green. And alright, so this is supposed to be blue. I'm gonna change that. The PDF that I'm actually gonna put in the link description would have the proper. This is supposed to be blue con here, not red con. It's in 2 places. The PDF that you'll find in the link description will have that corrected. And if it's not, just remind me, please. Alright, so that's the reason for this 3 here. And yeah, I think that's everything explained with the schematic wise. So obviously this is RD4. Let's just go back here. Yes, red con is RD4, RD6 is green con, RD7 is blue con. Alright, so remember I said before we flash it on, so BSF port D, turn it on, wait 10 milliseconds, and then we turn it off. Alright, and then we turn it off. Well, what this does is it actually it enables analog functionality for RD4, which is actually I'm sorry, I'm talking nonsense. It enables analog functionality for RA2. For RA2, remember the actual phototransistor, the sensor, what we're sensing, is connected here. So the sensor, the phototransistor is connected to RA2, right? So that's that, and then you set A and 2 up until A, and then you call Adc Conversion, which is a function to actually do the Adc conversion, and then out of that function we get the Adc result in Adc result H register, and then we send that sends red value. So this is the red value, and then afterwards what do? Turn it off, turn off the red LED. Right, explain again. So first off, you turn on the red LED, then you wait 10 milliseconds, and then afterwards, this in essence is you're just sampling. You're sampling here. You're sampling this particular pin to get the results, to get the sensor results when the red LED is on. So flashing, we turn the LED on. Now it's the photons are bouncing off the surface and going back, and we're reading what's being reflected off whatever surface back on this particular sensor here. Alright, so this red LED is on, bam, it's on the surface. There's that representation. Red LED on, bam, on the surface. We're getting readings. Voltage level of the phototransistor changes, and then voltage level is in essence what we save into sense red value, which is obviously digital value between 0 and 255, because we're operating in 8 bits. 10 bits, but 8 bits is what we're actually looking at. And then afterwards we turn it off. Alright, so this is in essence we're flashing the red LED. Next then we flash the green LED. Exact same thing, only difference now is RG6. Right? And then afterwards we get the readings for that, and then we turn off the LED. Same thing for RG7, which is for the blue LED. Wait 10 milliseconds, obtain the results, turn it off, turn off the blue LED. And obviously if you had more sensors, for whatever reason, you do the exact same thing, only this time instead of just saving for one sensor, you would also, so this is to obtain readings from one sensor. So if you had more sensors, you would literally just copy this and paste it like that. So this would be for 4 sensors, right? Obviously it will not be the same channel. I mean, if you had 4 sensors, you would need other ADC channels, and you would have to activate each of the other ADC channels and then save them. And also you would also need variables for each of them. So let's say you had 4 sensors. This will be sense 1 red value, sense 2 red value, sense 3 is red value, sense 4 red value, etc, etc, right? But yes, but in the end, obviously you have to turn it off. You have to turn off. Let me just make sure I'm doing it. Yes, that's the right thing. It's not crazy. Yeah. So in essence, in the end, then you'd have to turn it off. Turn off the LED for your default. Turn off the LED, and then you do the same thing for the green and the blue. That's how it is. Alright, let me just go back and delete everything. Everything returns to normal. Alright, that's that. So that's the sampling part. And then after the sampling, obviously you save the red value, green value, blue value, right? So that's what happens in the sample stage. And then now for the large test, this is the main part of the code. And then in the large test, first off, what you want to do is you want to make cause now you want to, if I go into that, okay, now you want to tell the difference between red, green and blue values, right? But remember, there's also white and there's also black. You want to know when it's black. Just put a right, and right, that's black, proper black. Right, so you want to be able to differentiate between all 5 colors actually: red, green, blue, black, and white. And you have to be careful with green and blue. Sometimes they're very close. Actually, let me just make this a little bit more darker. Okay, that's more purple, but I think let me just leave it there like that. I think that looks okay. It's kind of purple, but you get the idea. And that's that. And anyway, what you want to do is be able to differentiate between all these 5 colors. But differentiating between these 3 colors, red, green and blue, is pretty straightforward. You just compare them. But what about white and black? So in essence, before you start to compare all 3 values, because you just saved them as I showed in the code, you just saved all 3 values before you want to start comparing them. You want you want to make sure, you want to first of all check what's the value actually, what's the magnitude of the value. Is it too high, is it too low? If it's too low, then it's probably black. If it's too high, then it's white. I'm trying to speak low because it's really late at night and I really don't want to wake anybody up this time. Alright, so that explains that. So first off, you want to have a black threshold and a white threshold. So in here, I already set them up there. Obviously, that's where your calibration comes in. So you have to actually calibrate your sensor. And how do you calibrate hardware wise? So what you want to do is you want to get yourself into a space where you're not saturating your sensor. So that's why you have to tweak with this 2.2 mega ohm resistor, variable resistor. You tweak with it. You make sure when the sensors are on a white surface, this sensor is not saturating. Right, this sensor is not saturating when you sample it. When you call this function, right, it automatically saves into sense red, sense green, sense blue. You're gonna have to look at all those three values. If it's at 255, your sensors are saturated. You wanna overwrite, you wanna get them to a point where they're at about 200. Remember, the maximum is 255. You wanna get them to about 200, right? If your green is at 200, you're good. Usually the green returns the highest value, or and also if the red, green and blue values are varying too much on white, let's say on white one of them is the green is like 250, and on the red is what, 100 or something, and the blue is what, at 80, that's too far apart. What you want to do is you want to go back to your hardware. You want to go back to your hardware and tweak with this potentiometer. Remember, these tweaks with the brightness, tweaks with the brightness of red, tweaks with the brightness of green, tweaks with the brightness of blue. So you want to tweak them with the brightness to get them just right, so that they return something similar, relatively similar, not absolutely the same on each surface, but on a white surface, but you want to make sure that they're not too far apart. You want them to be at equal brightness, right? You want them all to be at kind of equal brightness. One's not too much brighter than the others, right? Usually the resistance you make for the red is usually higher than that of the green and the blue, so because the red is really bright usually, and you have to be careful because sometimes it burns a lot quicker than the others. But anyway, that's for you to find out. And anyways, like, back to where I was. So this is the white threshold and this is black threshold. So anyway, first off, you put it on a white surface. Then when you put it on white surface, you try to find out which one gives you what it is. You want to make sure your sensors are not saturated. Your sensor is not saturated, right? So you want to tweak with this value to make sure it's not maxing out, like it's not like 255 on like that. You want to make sure it's about like 200 to 220. That's a good place to be at white. And you want to put your sensors on black as well, right? So when you put it on black, you don't want to read zeros. You want to read something like 6, 10, 15, 20. Depending on how good your sensor, how do you say it, your sensor enclosure is. Depending on how good it is, then that's how you depending on how good your sensor enclosure is, and that's going to depend on how good and consistent your results are. Obviously the code matters, but believe me, there's no replacement for a good sensor enclosure and good good hardware, and that's also very important as well. And alright, so that's why I set the black threshold to that, white threshold to that. Okay, so that's that. So your large test. So under your large test, so first off, from my past experiences, I usually find that the green value is usually how do you put it? Usually returns the highest, right? So when you shine green, red, green, and blue on a white surface, the green, the white surface reflects more green in essence, is what I'm trying to say. So it reflects more green, but I know it doesn't look green, but you know, the green value is usually the highest one. The green value is usually the highest of 3, and so I decide to use the green value as my barometer to check whether the surface is black or white. So this is the test, this is the start of the test. So first off, you put it in working register, and then you check if it's the same as the green value, and if it's the same, then the sensor is black. So what this is actually, this is a register called sense call con, and obviously sensor color control abbreviation. This is a made-up register that I made up myself, and this is a made-up bit as well, sense black. So let me just go up there and show you what I'm saying. So under the C block, it's created here under the C block. The register sense call con is a register on the C block, and these are the bits of the register. Let me just go back down there and make sure. Alright, so let me just do this. Alright. Bits of the sense called con register. Alright, there you go. So this is sense red, sense green, sense blue, sense black, and sense white. Right? Tells you, obviously if you have more sensors, then you have to make this for 5 of them. There's probably other ways to do it, but this is the only way I know how. So yep, there we go. Okay, so go back to large test. So let's say, in essence, what this does, it puts the black thresh TH sense into the working register, compares it with the green value. If it's the same, it's going to skip this line, and then it's going to jump to this line here where it's going to clear the sense call con register, and then it's going to set the black bit, in essence indicating, okay, it's black, and then it's going to set this this is also another made-up register, made-up bit, but this we need to know how to light up the RGB indicators, the indicator LEDs. So obviously this will be black call, and this is a sense black. So after that, it's gonna exit the large test, right? It's gonna exit this routine, return from the routine actually, because now we know it's on black, because the green value is literally the same as the threshold. If not, it's gonna branch to this label here, and in the label now it's actually gonna check is it less, because it's not equal to now, is it less? So again, moves it to the working register, checks with the control, compare with function, skip if less than. So if it's less than, if this value is less than what's in the working register, it's going to skip the next line, and it's going to skip the next line now, which means obviously it's on a black. It's seen a black surface in front of the sensors. So the sensors are on top of a black surface. So it's gonna set a sense black bit of the sense call con register, and also it's gonna set the black call bit of the RGB con register. That's literally just for the RGB LEDs. And now we know the color, so it's going to exit the state. The function. It's going to return from the function. But if it isn't less, now we can start comparing, right? We can start comparing. Oh no. Sorry, we can't compare just yet. Hold on, I actually made a mistake here. Let me just change that to 1. Yes, I made a mistake. Let me just delete that. That's not needed. Okay. Yeah. In essence, what I just deleted is exactly the same thing. That's what this is. So don't be bothered too much about what I just deleted. It's exactly the same as this right here. So it's exact same. I typed the same routine twice, which is in essence unnecessary. So that's that. And also, look here, large test LT. So let's say it's not less than. Let's say we've checked here. It's not equals. It's not equals to the green. It's not equals to the black threshold value, and it's not less than this. It's not less than it. So we're gonna branch to this label here. And what the label here does is now it checks, is it higher? Is it equals to or higher than the white threshold? Right? So first it checks that. So that's what this subroutine is. It's essentially an if. So what this subroutine is if since green value equals to white fish cents. Right, so that's what this is. That's essentially an if statement. If it's equal, well, great, it's white. Well, it's on a white surface, and it's gonna do that. It's on a white surface. It's gonna send. First off, it's gonna clear that register of everything else, and then it's gonna set the sense white bit. Remember, this sense white bit up there, this is literally means 1. Look here, sense white. Sorry, it's actually equated to 4. So this, just do that. So this is literally equivalent to me just putting that like that, just saying 4. But obviously we put sense white because it's easier to identify this way, and it's easier to understand the code this way than just put in 4, which essentially we don't even know really what that means. So setting bit 4 of the sense con register, but actually setting the sense white bit of the sense con register. That's what we're doing. So this line says we're doing. And anyway, back to it. So this if statement, we check that out. If it's equal to the white threshold value, we set that, and then we set the RGB con, same one as well. RGB con register, which is a made up register, we set the white call. That's literally for the LED indicator. There's another function for that, which I'll show you. But anyway, so if it's not the case, if it's not equal, then we branch to this label here, and in this label, what we do here is now we're checking if it's greater. Is it greater? Is it greater? If it's greater, then we set the sense con, sense white. We set it, because if the green value is greater than the threshold, then it's a sensor on a white surface probably. And then after that, obviously RGB con white call. right? And then now we can return from the routine. Let me just show you what's at exit large test. Exit large test is essentially see, exit large test, as you can see there, literally return. That's it. That's exit large test. Alright, and then if not, we branch here. So here, is it equal to? No. We branch here. Is it greater than? No. We branch here. Right, and now here is where the actual comparison is. So now you could go through this whole entire thing, but in essence what it does is that first off, it compares blue and green together. It compares blue and green together, and whichever one is the bigger gets compared to red. That's essentially what happens. So let me just go through it step by step. So first off, we'll move the sense blue value to the working register. Then afterwards, we check is it greater than the green value. Right, if it's greater than the green value, if the green, compare with functions, skip it greater than. If it's greater than the green value, then we skip this line. And then we jump here where we now compare with the red value. Alright, so let me just explain that again because the words got confused there for a second. So first off, we move the blue value into the working register. Then afterwards we compare the green value to the blue value. And if the green value is greater than the blue value, we'll skip this line. So that's what this is, compare with function skip if greater than. And then we skip that line, and now afterwards we move the red value into the working register. Now we compare that to the green value. Compare the green value to whatever is in the working register. If the green value is greater than what's in the working register, we'll skip this line. Now what does that mean? What does that mean? It means we're on a green surface. Because literally it's a competition. The green value beat out the blue, and then it beat out the red, so it's green. And then what do we do with the RGB con? We set the green call bit of the RGB con register, and afterwards exit large test. Done. Otherwise, let's look at the flip side, right? Let's say the green value is not greater than the blue value, right? Then we jump to this label here. And then at that label, obviously the blue value, if the green value is not greater than the blue value. Now what does that mean? It means they're either equal, which is unlikely, which does not happen very often. It doesn't happen often at all. It rarely happens actually. So let's say the green value is not greater than blue. It means the blue is greater than the green, because they're not equal very often. They're not equal, they're equal rarely, let me put it that way. And so we branch here, and that means the blue is greater than the green. So now the blue, we won that little competition. Now we're gonna compare it to the red. So how do we do that? Move the red value into the working register, then we'll compare it with the blue, right? Which won that little battle with green up there. And then if the blue is greater than the red, what happens? We skip this line, and it's the blue one. So the blue, it's a blue. So we set the sense blue bit of the sense call con register, and then we set to the blue call bit of the RGB con register. Right. And then anyway, like let's go back to the top again. Let's say the green was greater than the blue, right? It skipped this line, right? Now we compared it to the red. Let's say it wasn't greater than let's say the red, like here we compared it to the red, but let's say the red is actually greater than the green. Now this would not be true anymore, so it will not skip this line. It will actually branch to this label here. Let me say that again, right? So first off, we compare the green to the blue. the green is higher. Let's say the green is higher, right? Now it's going to skip this line. It's going to jump right here. Now we'll move the red value to the working register and compare it to the green value, which we found to be higher. I mean, the only way we're able to get to this point is if the green is literally bigger than the blue, right? So now after that, now I want to see is green bigger than red. And obviously, if the green is less than the red, this line would be invalid. Compare with function skip if greater than. It would not skip this line because red is greater than green. Keep in mind this function says compare with function skip if greater than. What it's saying is skip the next line if this value is greater than what's in the working register. Actually, let me put that comment there. If since green value is greater than WH, right? This line says send, or this line says it's sends red value to working register. There you go. Then it will skip this line, and then it won't skip this line. It will not skip this line, right? It will actually branch to large test L6, and what happens in large test L6, it means the red is the biggest. It means it's on a red surface, and it's gonna set the red calcon, and it's gonna set the RGB red cal right there, which means it's on red, and it's on a red surface. That's what the sensor sees, and then afterwards obviously return from the subroutine, and that's what it is. I explain again like a brief overview. So first off, what you want to do is you want to make sure, let me do this, I know, right? It's very, very clear. Yeah, I just want to know where to put the, alright. Well, this seems like a good place. Alright, zoom in. Wow, very tiny. Alright, let me just zoom back in. So first off, check. Oh, I pressed the wrong button. So first off, what you want to do is you want to check that sensor is within range. And how do you do that? Check that sensor is within range. You first off check, is it equal to the black? Let me just put an if statement. If sense green value, let me just say less than equals to WH. Okay, because in essence, or let me say black thrash sense, right? Is it less than equals to black thrash sense? Less than equals to black thrash sense, right? Sense green value, is it less than equals to black thrash sense? So this is the equals to part of it. Compare with functions keep it equal, and then this is the less than part of it, right? And then afterwards, what you want to do is you want to check, is it greater than or equal to the white thrash sense. So in essence, you're checking the lower limit, and you're checking the upper limit. And if it's within range, within that, then we can go into comparing them, right? First off, compare blue and green. Green is the winner. Compare green. compare green to blue. If green is the winner, then you compare green to red. If green is the winner again, it's green. Or on the flip side, you compare green to blue. If blue is the winner, compare blue to red. If blue is the winner again, blue. If blue is bigger again, blue is the winner. Or on the other flip side, compare green to blue and green together. Green is the winner. Compare green to red. Red is the winner. Red is the winner of that, and then you branch over here, and red is the winner. Red is the bigger one, right? And yeah, that's that. And let me just say that again. Compare green to blue, right? If green is bigger, then you compare green to red. If green is bigger, then green is the color. You're looking for green is the winner. On the flip side, compare green to blue, right? Green is bigger, and you compare green to red. If red is bigger, then red is the color, right? Now let's go back to the top. Compare blue to green. Blue is bigger. Then you branch over here. You compare blue to red. Blue is bigger. Blue is the winner. Blue is the color. Still on the flip side. Back to the beginning. Compare blue to green. Here, blue is bigger, so we branch here, and then we go there. Compare the blue to red this time. Red is bigger, so what happens? We branch here, which means red is the winner. And that's the large test. As you can see, it takes some time to get used to it. I think you should maybe watch this part of the video 2 or 3 times, depending on how large your tolerance is. Alright, so that's a large test. And now for the RGB LED. Just jump there. So for the RGB LED, it's connected to both RA6, RC0, and RC5. That's what it's connected to. And so what in essence is happening is we're testing the red call bit of the RGB Con register. Remember, every time we actually identify the color, we actually, we set the red call, green call, blue call bits of the register. So that's what we're doing here. So first off, you want to check if this bit, red call bit of the RGB Con register is set. And if it's set, you want to skip this line and you want to turn it on. Turn red LED on. Right. And the other ones, you turn them off. Otherwise, let's say the red call bit is not set, you branch over here to this branch, and now we check if the green call bit is set. If it's set, then branch here, turn green LED on. Right. And obviously you turn the others off. Next, let's say the green call bit of the RGB Con register is not set. We branch here and we check the blue one. If the blue one is set, great, it's on a blue surface. You just say turn blue LED on. And there we go. Let's say the blue one is not on. We check the black. If the black call bit is set, if it's set, then we turn everything off. Turn it off. Also, if that's not the case, we branch here and we check the white call. In that case, we turn everything on. Turn it all on. Let's go. Turn all LEDs on. There it is. There you go. And afterwards, return. Right, and that's it. That's the RGB one. Again, I explain again. So first off, check the bits for the red. If it's set, turn red LED on as such. If not, check the next branch, green. If it's set, turn the green LED on. If not, check the next branch, which is blue. Bit test function, skip is set, the blue call bit of the RGB con register. If not, check the black call. If not, check the white call branch here. And if not, just exit. You're probably never gonna get to this scenario here. I just put that there just to have everything nice and, you know, wrapped up all nicely, I guess. Right, and this is just a delay and the ISR. There is no ISR, so that's that. Alright, so that's that, and all the other aspects of it is in essence initializing ADC, initializing oscillator, initializing ADC, initializing the port in it. The ADC initialization is essentially, okay, we're using AN2, clear the go bit, turn on the ADC. Clear F Adcon 1. What this does is it uses the VDD as the reference, which is 5 volts. Considering, let's say, your power in 5 volts, it's going to use the 5 volts as a reference, and it's going to use the ground as a reference, which is 0 volts. What else is it going to do? That's about it, actually. And the Adcon 2, if you look in your data sheet, alright, let's just go there, and ADC registers. Alright, you go to Adcon 2, because right justified. It's right justified. No, is it right justified? No, it's left justified in this case, because we're dealing with the 8 most significant bits. So it's right left justified. So that's why the first bit is 0. As you can see, 1 1 1 0 on 0. The next so I think I should do in there 0 on 0. 0 1 0, which is 4 TOD acquisition time select bits. And the last but not least is 0 on 1. Did I get the other way around? I think I did. Anyway, so my bad, this is not implemented, so it's 1 0 0. This was actually 1 0 0, which is 8 TAD, and the last 3 is 1 1 1, which is FRC clock derived from a dedicated internal oscillator. So 1 1 1, or you could use any other settings, and that's the initialization of ADC. And Adcon 1, obviously, it's just always set it to 0, because, you know, bit 7 0. I mean, this is all implemented as 0, and the one that really matters is here, ADVREF plus connected to internal signal AVDD, and negative voltage reference configuration bits 0 0 is in essence use the VREF minus, make that the VSS, which is 0 volts. Alright, and that's that. And port in it, in essence, all the digital output ports we're using, obviously this is to turn on the red, green and blue, flash them. Anyway, we need to ensure, and the indicator LEDs, we need to ensure that analog functionality on all those pins are disabled. So that's what this is. And how do you know what analog pins are connected to what? To what? Table 3. Is it table 3 or table 2? Table 3. So we have RD, let me check again. So we connected RD4, RD6, RD7. That's what's connected. RD4. So you go to RD4, RD4. So RD4, RD6, RD7. So you have N24, N26, N27. So you have to clear them. You have to clear them. Analog functionality, disable analog functionality, and enable as digital output, and clear it because you don't want the LEDs just flashing on out of nowhere. And then you sort it. And now for the ADC conversion. With the way you do an ADC conversion, first off you set the go bit of the Adc 0 register, and you set the go bit, and then you constantly poll the go bit. So once it goes to 0, ADC conversion has been completed. Once it goes to 0, then you can move the results. So ADC, AD, RS, H, you move that into ADC result H, and then AD, RES, L, you move it to ADC result L. And because it's 10 bits, so the 8 most significant bits is what you find here. And yeah, that's it. That's about it. Now I'm just gonna show an example. Obviously I don't have my hardware here, so I'm just gonna comment that out, and I'll comment this. Alright, so I'm just gonna put a nice breakpoint there, and in the watch window, and just show you have sense call con here. And in essence, from the sense call con register, these are the bits of it. Well, the bits that I am considering for it anyway. So sense red, sense green, sense blue. So for this particular scenario here, so I artificially put these values into it. So now, as you can see, the sense green value is at 10, right? So which makes it black. So what we expect is to have the fourth bit number 3 of the sense call con register to be 1. So now I'm just gonna run it and bold. Unfortunately I can't. I hope you can see. Here, as you can see, the bit number, the fourth bit, which is bit number 3, is a 1. Right? That's a 1. And as you can see, the value for the sense green value is 10, which is less than 15. Right? Which is the black threshold sensor. So now let me change the green value to 160. To 160, which is greater than the white threshold. And now what we expect is, so you see the sense white bit, that's the 5th bit, which is bit number 4. So we expect this particular, the 0, the one next to the 1 on the left hand side, we expect that to be a 1 this time. So let me just debug again. It's a 1. It's a 1. I hope you can see that. It's a 1, which indicates that the white sends white, that this particular bit is the one that's set. Right, now I'm just gonna try for the blue, for the green first. Now for the green one, so I'm just gonna make this 70, the green value 70. It's within range and it's higher than the red, which is 30, which is in the blue, which is 60. So now the bit that's expected to be 1 is bit number 2. And that's it. So this is bit number 1, bit number 2, and that's a 1. And now next I'm gonna change the red to 90. Now the red is the highest one, and now we expect the first bit to be a 1. The first bit is bit number 0. As you see there, the bit 0 is actually 1. Right, now let's change the blue to 100. Now the blue is the highest one, and now we expect the third bit, which is bit number 2, the third bit, which is bit 2, to actually be a 1. See bit, and the third bit, which is bit 2, so this is 0, 1, 2, and yeah, which means the large test is functional. And yeah, so that's that. So if this doesn't work out, this code doesn't work out, it's probably an issue with the Adc initialization. You have to look at that and get back to me on that. Try to fix that. Alright, so that's that. And everything else is just run-of-the-mill stuff, really. So, you know, this is configuration bits, and you know, this other bits, these other bits, and yeah, that's pretty much everything. General recap. So first off, you start the code by initializing the oscillator 4 MHz, initializing the ADC, then initializing the ports, initializing the ADC. We're using the AM2 in this particular example. Initializing the ports, in this case we have 6 output ports, 3 for indicators and 3 for actually controlling the flashing of the LEDs. And now we have the white setting up the white threshold, which I guess in the beginning you have to comment this out, to actually, you have to comment this out in the beginning, and only have this and that. Literally, actually all you're gonna need in the beginning is this, and you just put a breakpoint there, and literally all you want to see is that your sensors aren't saturated on white, and they're not completely zeroing out on black, and that they're relatively the same value for all the colors whilst on white. So you basically put it on there and do this and have everything like this, and literally just go into your watches. Obviously you create one for sense red value, sense green value, sense blue value. You create a watch window for that, and you literally just sample the sensor on white and ensure that they all have the same one. And as you're doing that, if they're not the same, what you want to do is, first off, you want to tweak with this guy to make sure they're not saturating. When you confirm they're not saturating, like the highest one is about 200, not 255, 200 to 220 is fine. Then you start tweaking with these variable resistors right here to tweak with the brightness of the LEDs to try to get them to be on the same, level. It's important that you connect them as such, especially if you're using multiple LEDs in parallel, because you can't connect too many LEDs. You can't connect LEDs in parallel to one microcontroller pin. You can literally destroy your microcontroller, because there's a limit to the amount of current it could actually output on each pin whilst maintaining the voltage. Alright, so so that's that. So you do that for a while first, and then after determining that and your white threshold and your black threshold a reasonable one, so let's say on your let's say when you put it on white, let's say you read let's say you're reading consistently let's say 160 for white on the sense green, on the green value right here, on the green value. Let's say you're reading 160 consistently. So what you want to do here for your threshold, you want to take that, you want to say that minus 10. So let's say it's 160 that you're reading consistently around that value for your green value. When your sensor is on a white surface, you want to make the threshold here, you want to make that less than 10, just to make sure that whenever it's at 160, you know for sure it's gonna register as white. So you want to make your threshold 10 less, right? And then exact opposite for black. Let's say you get a sense of you put it on black, and the value you read for the sense green value, let's say the value you read is like 20. You're constantly getting 20. So what you want to do for your black threshold is you want to add 5 to that. So you want to make that 25, right? So that's what you want to do. When you make that 25, you're going to add 5 to it. But obviously, just leave it at 15 here for the sake of this example. And then after you get those two values, you copy them in here, and then you can uncomment everything else except this particular ones, right? This is just for the sake to show that the large test works in this coding scenario, in this particular scenario, without much hardware. And then anyway, after that, then you call your sensor back to the overview to sample sensor RGB, essentially flashing red, green, and blue, saving those values, and then jump into your large test, comparing the values you saved, and then after that, output in the LEDs. And then when you compare the values you saved, you have to set bits for them. So if it's a red, you set the red bits. If it's green, set the green, blue, black, white, right? And also set the appropriate bits so that you can output them on an LED. Something to help you output them on an LED in an easy way. Obviously there's another way, but I find this to be the easiest way for me anyway. Alright, so that's about it. Take a look at the code, ensure it makes sense. Yeah, it's available. Look at it. Try to make sense of it. I'm sure this is a very long video, but it's important to ensure that everything is try to explain it as much as I can to make sure there is no unnecessary confusion in it. Alright, all the best with coding color sensors.